Hi, I'm going to outline a simple framework for putting together simple user interfaces. These are the components I'll be using: one development board, one LCD display on the I2² bus, and one rotary encoder switch. First, I'm going to outline in pseudocode what I plan to do. We're going to want an array of functions for all of our contexts. Function 1, function 2. Next, we're going to need a context pointer, and then each context is going to want its own state. So the context will need to have its own state, as the context will need to know if it has been initialized, or if it's warming up, or if it's running. And then you're going to want an array of menu functions. So each item in the menu for any one context, so the menu in context 1 might have go home, go to next page, and each one of those items in the menu will need a function that will perform the context change. And then we're going to want a pointer to keep track of which menu item is selected. Then we will have the actual function. So the first thing we're going to want to do is look at the state. If not initialized, then you're going to want to initialization. If we're in a working state, we're going to want to check any variables which are to be displayed. So we're going to need to cache any variables which are going to be displayed. If we have a variable called var1, we're going to have to get the live value of var1 and then check to see if it has changed since our cached version. The next thing we're going to want to do is to see if the menu item that is selected has changed, as the user is going to want to know what menu item a button press will activate. And then the last thing we need in our function is if menu enter press. So if the user has pressed enter on the menu, we're about to change context. We're going to want to reinitialize the state, stop any processes that are running, and then update the context pointer. And then in the main program, go while true. We're just going to call the function inside our context array. So on a higher level, we're merely looking for on context change, and we're also going to be constantly looking for variable changes which will be specific to any one context. And then also we've got on menu pointer change. I'm using a rotary dial switch. With the 2-pin side, we have what functions as a simple push button. On the other side, we have 3 pins, and 2 of these have a rotary circuit which sends out pulses as you turn the dial, with one of them out of phase with the other. So now if I turn the dial, we've got a pulsing signal. And if I put the oscilloscope on the other pin, we have a pulsing signal again, but this is actually out of phase with the first signal. With those pulsing signals being out of phase, we can tell which direction the dial is being turned. So the benefit of using a rotary push button is that on our hardware user interface, we can have left, right, up, down, and enter with only 3 I/O pins. Here I have the schematic of the circuit I'm using. This is the ESP32. I've got 2 inputs to 2 potentiometers, and then I have 2 inputs for the rotary encoder and the button press of the rotary encoder switch. So here's the rotary encoder On the right hand side we've got the 2 pins which function simply as a button press. And then on the left we have the 2 encoder pins. Then we have the LCD display with the I2² bus. I'll quickly run through the code derived from the pseudocode that I sketched out. So we have a function for the main screen, second screen, third screen. Then I have an array of these functions and a pointer to the item in this array. So all that exists in the main loop is a call of the function that exists in the array at the specified pointer. So now let's have a look at one of those context functions. So the second context, and correspondingly this second context has a strut. So I have a ball value specifying whether or not it has been initialized. I have a pointer for a array of functions which represents the menu in that second context, and then I have a cache of a variable, and this pointer value and this max value corresponds to this array. So when this context function is first called, the isInitialized variable will be false, and so we draw the initial display screen. Then we read the live value of the variable ACDA. So as soon as the live value differs from the cached value, we need to update something on the display. So the next thing to do, we read from the encoder which direction the pointer is going to shift, and then update the menu section of the LCD display accordingly. And then lastly, we check to see if the button was pressed on the encoder. If the button was pressed, we need to call the corresponding function in the menu for this context. And then we need to reinitialize the data. So the encoder basically works on a timer interrupt. So in the service routine of the encoder, pin A is checked to see if it's changed, i.e. whether or not the encoder has been turned. Then if the encoder has been turned, we then check with pin B, and due to the out of phase behavior of pin A and pin B, the state of pin A or pin B at 80 milliseconds after the first check will either be the same or they will be different, and that corresponds to whether or not the encoder is being turned to the right or to the left. And then in the same interrupt service routine, there is a software debounce of the mechanical button of the rotary switch. So when I turn this rotary dial, I am changing the menu pointer, and so I am having to refresh the display. When I press enter, I am changing the context pointer, and so I have to reinitialize the state of the context I was on, change the context pointer, and then update the display for the new context. And then here we have a variable being read. In this case it's from this potentiometer. In conclusion, it's not actually that hard to make a hardware user interface, and using a rotary encoder switch is an elegant way of providing user input. Now, one of the most difficult things about making a hardware user interface is actually packaging it appropriately, as you have to take into consideration dust and moisture in the environment in order to protect the hardware. 3D printing has helped with this issue somewhat. Because of this complication, it's quite tempting to want to rely on radio such as Bluetooth or Wi-Fi in order to provide user interaction with the hardware. But it is very tiring being expected to use a mobile phone for everything, and it would be nice not to need to rely on it. So for that reason, I would say there's definitely still a place for hardware user interfaces, and I would encourage more people to incorporate them in projects.